Okay, good evening and you are welcome to class. We're having a primary mathematics curriculum this evening. Primary curriculum. And in the previous class, we stopped at the concluding part of Unit 1. We summarized Unit 1. So in this class, we'll start with Unit 2, which is features of the new 9-year basic mathematics curriculum. We have actually looked at the new 9-year basic mathematics curriculum. Mm, but we want to look at the features. And in this unit, our focus will be on the following items. We want to be introduced to the new national mathematics curriculum for basic education program. We want to know why we teach mathematics. Okay, sorry. Let's not mix things together. We are done with this part. We have done this part. Um, no problem solving. I remember that very well. Excuse me. We are meant to do um, mathematics as reasoning. I believe that is where we stopped. Is Madam Titi here? Madam Titi is not in class yet. Okay. I guess I'll just hold on a bit for you guys because you have to be here. The class is your class. Okay, so let me see how much content we have here. Okay. This the material is very funny. How did they left a whole page? Okay, you are here. Good evening, ma. You're welcome. Okay, we stopped at 3.4. So we start from 3.5, right? I've seen that too. We've done mathematics as communication. So we are to start from mathematics as oh, sorry. So we're actually starting from 3.4. Mathematics as communication. All right, that makes sense. I will be doing a lot today. Mathematics as reasoning, and so on and so forth. Okay, you are welcome. Good evening. How has been your day? Here comes, you know, the ones I like very well. History of WhatsApp. What is it? It's full of stories. Anything that is not involving solving and logic and the rest of them, I'm not really interested. Okay, I promised in the last class on Wednesday or so. Sorry, on Tuesday, or was it Thursday, that I will try to create more assignments for you guys on your courses. Unfortunately, hmm, I was unable to do that. I have a lot of work on my desk this time around. Okay, let's get to work. Since we are trying to talk about mathematics as a communicator, Yes, Madam Comfort, you are welcome. It's nice seeing you here now. So the class is complete. All right, let's get to business. Like I like to do, Madam Titi already knows that. We always like to start from what's it called now? We always like to start from reading the material. We'll read everything that is there, then we'll start criticizing. That is, we start looking at it philosophically by explaining why did this one happen, how better can it happen, what are the advantages, what are the disadvantages. So we started that approach since we read about one of your courses that talks about philosophy, and we were able to bring out the fact that philosophy means a kind of system or method that helps to simplify concept. If you just say love now, love is an ambiguous word. If you look at love philosophically, you are going to have a whole 1,000 pages of book filled with details, questions, trying to get to the root of love. So that is how to look at things philosophically. And that is the approach I've been using since we are teachers. We need to read what is there, then we look at it critically by looking at the core definitions given there. Are there examples given? Are there advantages or disadvantages? So that is how we do. So let's start with mathematics as communication. We have been looking at the 9 years basic mathematics curriculum. Now we have talked about a lot of things, and today we'll start from mathematics as communication. Now let's read before we start criticizing. The curriculum clearly states the curriculum clearly states that one of the objectives in learning mathematics is to acquire the ability to communicate ideas through the use of mathematical symbols or ideas. An essential part of the curriculum is to help students attain the ability to comprehend mathematical statements encountered, for example, in the math. In mathematics lessons, students are encouraged to work in groups on certain projects or problems. And I think that is the end of mathematics as connection. So we've done the reading now. What are the things we can bring out from this very short paragraph that we finished reading? Now let's try to criticize it. Let us try to criticize it, and this is what we are going to do in our criticism of that part. I'll start by saying, what is the meaning of mathematics as communication? What is the meaning of mathematics as communication? The first thing we are going to bring out there from the first paragraph, first lines that we have there, is that they are trying to tell us that mathematics is not only about solving calculations. Mathematics is a language. That is the idea they are trying to pass there. That this math you are seeing, it's very simple or very easy for you to conclude once you hear mathematics. That is numbers 2 plus 2, 1 plus 1, 3 divided by 2 or something. That's what comes to your mind. But you never imagine it that math is a language. Like you have English language, mathematics is also a language. Let me give you an idea. If you are not good in math at if you see expressions that seems to use logic or that are mathematical, you will not be able to interpret them. That is to show you that mathematics is a language. So those that are very good in math, there is no symbol, no expression they see anywhere that they will not be able to talk about, read, or interpret because they know the language of mathematics. So you as a teacher, you must know that that math you are teaching is not just to help them solve 2 plus 2. You are inculcating in them a language, a logic language that they can use to interpret several other things in the future. And what is the language of mathematics all about? It is a language that communicates ideas, facts, and even information based on what we are seeing in our front here. So, like English use Like if you are speaking in English now, you may be speaking your thoughts, what you're actually thinking, you speak it out. Mathematics on its own, it uses numbers, symbols, diagrams, graphs, tables, or formulas to communicate information. So if I'm a good mathematician, if I see a quadratic equation used to express a real life event, from that quadratic equation, I can interpret clearly the situation, the real life situation you've just written in mathematics. That's what we're trying to say. Mathematics as communication. Mathematics is a language. So instead of writing, for instance, if you are to write in words, if I should say five, okay, let me give us an icebreaker. I will drop an English language in your chat box now. I want you guys to write it in mathematics language. 5 plus 3 equals 8. That is the that one is English language. Now I want you guys to write it in mathematics language. So you now see that mathematics communicate. This thing I've written here is in English. I want the mathematics version of it. So, and then according to the curriculum, one of the major objectives of learning mathematics is that it helps students to communicate ideas using mathematical symbols. So a child now, instead of telling you that you can carry 150 apples, then if you sell 30 out of it, then you have 90, sorry, what am I saying, 120 left. And then instead of using that long this thing, a student who is good in mathematics can just say 150 minus 30 equals to 120. That's what they are trying to say, that the idea of the curriculum of 9-year basic mathematics for the primary and junior secondary school is that they want your student or your pupils that you are teaching mathematics to be able to communicate ideas using mathematical symbols. That is number one. I have not seen your responses there. Your responses are not showing. I hope my network is not bad. Madam Titi, you've written something and you deleted it. I don't know what that was. 5 plus 3 equals 8. That is the classwork that you have to do in, you have to write it in, what do we call it now? You have to write it in mathematical symbol. It's very simple now. 5 plus 3 equals to 8. Okay, that is correct now. We have the correct thing there. Okay, so we're now trying to look at the part of the paragraph, that the curriculum. So number one thing is that you are not just to teach them 1 plus 1 is 2, 2 plus 2 is 4. You have to teach them how to communicate ideas using mathematical symbol. Another thing the curriculum mentioned is that it helps the student to understand mathematical statements. When they see the use of symbols like division, multiplication, subtraction, bracket, you know, different type of equation like quadratic equation, simultaneous equation, algebra, and all the rest of them, they should be able to understand those statements. Then the curriculum also states that the students should be able to explain mathematical ideas clearly. There is something you call word problem in mathematics. When you know that one of the most difficult logic to interpret for students, when you use word problem, when you use word problem to issue out a classwork to them, so they will need to first interpret the word problem into mathematics before they're able to solve it. So the ability to explain ideas clearly in math is one other reason why you want to teach them mathematics. And saying that, we are done with all that this particular part of the material is talking about, mathematics as communication. And I think this method you are using is very good. We first read, then we criticize. We look at it philosophically. What are they trying to teach us? What are they trying to help us know as teachers? So the next thing we are going to is 3.5. mathematics as reasoning. Mathematics as reasoning. In fact, this one is very straightforward. You already know. In fact, the easiest one for you to say mathematics is that mathematics is reasoning. Because when they ask you what is mathematics, you may not think that mathematics is a language. Your mind may not go there. You may not think that it's a means of communication. But this reasoning is very straightforward. It's one of the things you can easily come up with yourself. So let's see, how is mathematics reasoning? We'll read first. The main goal statement, the main goal statement clearly states that the student need to develop the ability to think logically, systematically, creatively, and critically. Although this is not clearly stated in the syllabus, teachers, okay, excuse me, teachers what? They left a whole page blank. This is funny. Now, teachers' guides and further elaboration of the syllabus, especially syllabus specially encourage teachers to use mathematical thinking or reasoning. The use of statistics to critically examine information. For example, can be said to be in correspondence. They actually made a very good point, but this their information, what is provided there, seems to be confusing to say. But let's look at it critically. And I think there is not we don't have much things to look at in this part. A lot of things, but I noticed I jumped something in the last part, mathematics as communication. They mentioned something about interpretation of media content. There was a mention of social media, interpretation of media content, blah blah blah, and so now what that in that part that talked about interpretation of media content. Why is it that material like this, jumping and jumping and jumping and jumping? Okay, let's get this straight. So the curriculum for mathematics education, especially for the 9 years basic whatever, it expects students to be able to understand mathematical information on media, maybe on the media. Let's just say like all this mass media, like newspaper, television, radio, like magazines, and the rest of them. Now, what are we saying when we say that they should be able to understand mathematical statement or information in the media? The thing is, there are sometimes that they'll be reading the news, or yes, maybe reading the news, and maybe the news caster says a candidate or candidate A scored 55% of the total vote. For instance, if that was a statement made in the radio during a news or a report, candidate A scored 55% of the total vote. If they already know mathematics language, they know what 55% means. That's what they're trying to say. They already know that when they're saying 55%, in everything we have 100%. So if somebody already got 55%, it means the whole thing is left with 45%. So it helps them to understand any statement made in relation to mathematics, any mathematical statement made anywhere, they'll be able to. Now, another thing that we can see there is that under mathematics, sorry, what am I even saying? Yes, this part that we're talking about now, mathematics as reasoning. You want them to, there is this particular statement made in this part that said you should be able to use scenarios that will get them into thinking. We've done something similar to this in one of the other definitions of mathematics. where you use real life situation to get them thinking critically, logically. You know, all those word problems that you use, like if Ade, if Ade is 10 years old now, and Ade's father is maybe 35 years old, 20 years ago, how old was Ade's father? You know, those kind of word problems that you give them. That one helps them to think logically. It develops their reasoning. They start reasoning in their brain. Okay, if somebody is 10 years now and the father is 35 years, as in now, if you now go back 25 years ago, how old will the child be? They start reasoning. You see, there is a kind of reasoning that goes on in their faculties. So they start reasoning, that develops their reasoning ability. Not only that, is not the only examples. We have several examples you can use to develop their reasoning. So in an attempt to solve mathematical problems, especially logical problems in mathematics, it's not like you giving them 1+1 that develops their reasoning. As in logic related problems in mathematics, that helps their reasoning ability to be improved or developed if they've not developed it yet. So that is what we are trying to say. Then the last thing we'll be doing under the different definitions of mathematics we have. But before then, I want to test us on something. If I should say that, okay, I think I better drop it in the chat box. But what I want to ask you is, if I should say that, let's say inflation increased from 18% to 22%, from 18% to 22%, what will you say? What is the meaning of that? If I tell you to interpret this is a mathematical statement now. In put it to English language. It's a mathematical statement now. Interpret it to English language. That is what I'm trying to say. We have a mathematics problem there. Inflation increased from 18% to 22%. Literally, what would that mean if you are to interpret it? So while you are reasoning that out, let's go to mathematics as connection. Mathematics as connection. Or sorry, it's mathematical connections. Mathematical connections. That is our next concern. So while you are trying to solve the question in the chat box, let me read this one. We'll read first, then we'll explain. There is too strong emphasis in making connections within mathematics itself and across other subjects. In fact, the title of the curriculum suggests that making mathematical connections within itself or across other areas of study is strongly suggested. Making the connections between mathematics studied in class and material from everyday life or the environment are explicitly stated in the document accompanying the syllabus. Now, through through the introduction of certain facts concerning historical development in mathematics, the curriculum hopes that students should be able to see that mathematics has its origin in many cultures, and is developed as responses to human needs that are both aesthetic, both in utility and in aesthetic. So what are we saying here? That is what they have for us there. So, okay, Madam Titi said there is 4% increase in the. Thank you, Madam Titi. Now, that is reasoning. That's what they're trying to say, that the student, the pupil should be able to attain that level of reasoning when you give them that kind of, questions. Okay, so what are we trying to say as, under mathematical connections? First of all, what are these connections that we're talking about? When you talk about mathematical connections, we are trying to say what are the links, or we're simply saying that the linking of mathematics to other things. The linking of mathematics to other things. And the examples of connections, as mentioned in that paragraph, we have linking mathematics topic to another, sorry, linking one mathematics topic to another, that is within mathematics, linking one mathematics topic to another. For instance, you have done addition, now you are doing simultaneous equation, and inside simultaneous equation you need to add functions, you need to add some functions together. So you need to recall what you have done in addition before you can solve simultaneous equation completely. You must know how to use division very well if you are doing logarithm. So those are the things we are trying to say, that within mathematics itself there is a connection that is ongoing. You link one mathematics topic to another. Then another type of connection mentioned here is linking mathematics with other school subjects. Linking mathematics to other school subjects. You know how that works. You know that in several other subjects you do, there are some of them that in fact basically requires the knowledge of maths. Another thing is linking mathematics with everyday life. That was the other connection mentioned there. What are we looking at now? The types of connections that exist in mathematics. One is linking one mathematics to another mathematics topic. The other one is linking mathematics to other school subjects. The one we are talking about now is linking mathematics with every what we are doing on daily basis. You want to measure the salt that you put in your food when you are cooking, so you use mathematics. Well, I know that in Nigeria we don't measure it, we just use our ancestors spirit, start pouring it until our ancestors say it's okay. That is fine. I think we are naturally good in adding salt to meals. Now, another type of connection mentioned there is the understanding of how mathematics developed through history and different cultures. The understanding of how mathematics developed through history, you know, and different cultures. Now, connections with within mathematics. If we are to look at that one explicitly, we it means that when you understand one topic in math, you likely understand the other. Like I've mentioned, the issue of addition and simultaneous equation. Now, if you understand fractions, for instance, it is easier for you to know how to do percentages probability. Why? In all of those other topics, you need to divide, you need to use fraction. So the knowledge of fraction helps you to do percentage very well, or ratio very well, or decimal related problems very well. When we say connection with other subjects, let's give an example. In fact, the subject that seems to be very close to that is science. You know, scientists use mathematics to measure, to calculate, and to conduct their experiments. So, for example, now in chemistry, a chemistry student measure the volume of a liquid using mathematical calculation. That is the relation. And even if you are a geography student, you use mathematics to calculate distance, to calculate map scales, population statistics, and so on. A student in economics now will use mathematics for calculating profit, loss, like interest, like percentages, and the rest of them. And even a student in agriculture will also need mathematics. Why? They will need it to measure land, to estimate the harvest they are expecting, calculate fertilizer that's required for, you know, the success of their plant life. Now, when we now talk about mathematics with everyday life, let's look at examples that will help us to understand that mathematics has a connection with our everyday life. For instance, when you want to go to the market, or when you actually go to the market, you use mathematics in a lot of ways. You can calculate the prices. Okay, give me 5 sachet of salt, give me two pack of maggi, I need 1 bag of rice, I need two bags of semo. Now after you've done all that, how do you know the total you are going to pay? You use mathematics. To use mathematics to calculate prices, to count our money. If you don't know math, you'll not be able to count money. That is even how how important mathematics is. You can't even count money if you don't know math, if you don't have the knowledge of counting. So you also mathematics will help you in your daily life to receive the correct amount of change. You bought something of 750 and you gave the person 1,000 naira. If you don't know mathematics, if they give you 200 naira as your change, you'll be confused. Or if they give you 150 naira as your change, you will think that 750 plus 150 equals 1,000 naira. So how mathematics is important. It helps you to calculate or to receive the correct change when you get things in the market. Now, even in your home, you use mathematics a lot. You know, when you want to cook, you use it to measure your ingredients. You can use math to tell time. It's 4 p.m. It is 5:32 p.m. 32 minutes after 5. And then you can use to calculate your bills, like probably how much did you spend on electricity, how much did we load as prepaid last month, and so on and so forth. Like those of you that like traveling a lot like me like this, we use it to calculate distance. How long before I go on any journey now, I'll first enter my Google map, put my current location and my destination, then I will check how long will it take me. It's mathematics. You know how long it took you to travel and even the distance you covered. So um there was one thing mentioned there which I would like us to pay small attention to. They said mathematics developed to meet human needs. What does that mean? What does it mean that mathematics developed to meet human needs? The reason why people saw the need to actually adapt or learn the concept of mathematics is that there are needs. We had needs then, and some of those needs are the needs in counting of goods, needs in measuring of land, needs in building houses, needs in like trading in the market, like keeping of records and even telling of time. We had needs. So that was the reason why mathematics had to develop over time in human society. There's another thing mentioned there about the aesthetic value. When you say something is aesthetic, you're actually talking about beauty. You are saying that mathematics is beautiful. Mathematics has the beauty aspect of it. You know, they mentioned that in the ending part of that paragraph. They said, where is it now? Okay, this is where I am. In fact, that is the last thing there. So in utility, that is utilitarian and aesthetic. And what is the meaning of aesthetic? It means beauty actually. The other word for it is beauty. And if that is the case, what we're trying to say is that people admire mathematics. Why? Because mathematics has patterns, it has symmetry, like it has order, it has logic, and so on and so forth. For instance, now, do you know that most of these designs that you have in beautiful shapes, like patterns found in shapes, like designs, and all those geometric figures that you see around you, they are the ones that show the beauty in mathematics or the beautiful part of mathematics. If you look at all these geometric figures, you know, like shapes, you have like cupboard, you have rectangle, triangle, and all those stuff. Those are beautiful things to behold. And that is where we hang boot on mathematics. Now we are going to something that's entirely different from what it is. We have been looking at what it is. Now we are going to this aspect of it, the organization of the 9 year. The people that wrote this material, goodness, they just fumbled everything together. You don't even know what is on. Okay, let me zoom it in. I hope it's not from me. No, that is how they made it. That is how it was made. I think the thing is too wide than A4. Now I'm trying to look at examples of this curriculum format. This is for primary one, and this is a topic that I want to teach them number and numeration. I know people know what we are trying to do because you've been doing it. Excuse me, and you probably know the topics that you do or you treat in each of those subjects. Now, sorry, classes rather. So in primary one, now we have number and numeration. You can see their performance objectives, the content, the activities, teaching and learning materials, and then the evaluation guide. I know Madam Titi already know by now that everything you do as a teacher, all these are courses, always stress the importance of evaluation. Not only will you take them through a process, you must evaluate their understanding of that process. That's why we have tests, we have group works, we have examination, and so on and so forth. Now, uh, these table numbers, then we have under performance. They are meant to, pupils should be able to sort and classify numbers of objects in a group of collection. Under content, they should be able to sort and classify objects leading to the idea of 1 to 5. That is in primary one, numeration. What will the teacher do? You as a teacher that want to teach them this topic, what will you do? One, the teacher brings objects such as beans, bottle tops, buttons, and nylon bags. The teacher also mixes the collection and asks pupils to sort them according to types, while the pupils bring various objects such as beans, bottle tops, buttons, and nylon bags to the class also, and then they will sort each of them according to their types. The teaching and learning materials, well, the counters which serves as things like stones, beans, we've all done this in primary school. That time they will ask you to go and be looking for during our own time, it's not all this bottle water cover. It is the cover of all those bottle mineral like 7 Up, all of them like that. That's what we pick around to count. But now this generation, they're very lucky. Now the evaluation guide, pupils to sort given number of objects from the collection. Then we have the circuit splitting is this. I think I'll look for the complete listing. You don't even know the topic you want to teach them now. So reading this thing is not valid. You don't know the topic. They are just giving you the uh, format. It's different, like the objectives, the activities, and everything. So when we get our hands on the full content, we'll be able to study that. And that is where we are likely going to conclude this topic on mathematics, 9 years basic curriculum. As a form of conclusion, I think we may come up higher now. The new basic mathematics curriculum emphasizes that mathematics should be taught in connection with its usefulness as an everyday activity. You see, they just want a shift in your idea of mathematics. Initially, you might have the opinion that mathematics is just all about teaching, but now it's no longer that. It is now teach them apply mathematics on daily basis. When they see things that requires mathematics or things that deals with mathematics, of course they should be able to apply those concepts to their day-to-day living, to their everyday lives. I have dropped an icebreaker there while I'm trying to conclude. That's an icebreaker. Now, in summary, mathematics could be seen as a problem-solving activity in all areas of life, as a way of communication, as a way of reasoning in diverse areas of life activities, and as a way of connections of ideas. Haven't done that. We have done and concluded that part. Now, the next thing we'll be talking about no longer the 9 years basic curriculum. Our concern will be Unit 3. Yes, usefulness. Thank you. In Unit 3, we will talk about components of effective mathematics instruction. If your mathematics instruction, how you will instruct your learners, your pupils, your students, how you will teach them, if that your teaching method and style will be effective, what are the things it will contain? That is what we want to learn. And what we are going to look at in that unit, we have just some few things to consider. One is the effective kindergarten to grade 4 instruction. That means a type of instruction style that fits kindergarten kids and all through grade 4 level. So that their category, we have an effective method for instructing them in mathematics. The second thing we will look at in that class is to look at teaching primary 5 and beyond. So kindergarten to grade 4, that is primary 4, one method. Primary 5 and beyond, another method. Then teaching through a concrete to representational to abstract sequence of instruction. These ones look like Chinese for now, but don't worry, when we get there, we'll break it down. Teaching through a concrete to representational to abstract sequence of instruction. And the last thing we'll look at in this unit is using concrete manipulative to teach mathematics. Using concrete manipulative to teach mathematics. I just pray I will have the energy to quickly upload assignments for you guys. Madam Comfort, please, if you have not created your assignment portal, message me after the class. Let me quickly do so. Or if I have done so, but it's the one of the general class that you have, that which one did I put there for you guys? Maybe just 102 or something. So just message me. So I will put all your remaining courses, even though I've not uploaded their questions yet. I will do that very soon, so people can start practicing some of these things we have done already. So I believe we have used the time effectively. The next class is starting by 6, and I think that is Edu 112 or so. But we have another class this evening. We're having 2 classes today. Do enjoy the short break. See you by 6 p.m. Thank you. So, Madam Titi, as a form of reminder, we are starting the next class from Unit 3, Component of Effective Mathematics Instruction. Thank you.